The question says that two charges, 2 microcoulomb and minus 2 microcoulomb, are placed at points A and B 6 centimeter apart. Identify an equipotential surface of the system and what is the direction of electric field at every point on this surface. Now we know that electric potential is defined at a distance r from the charge q as kq by r. Now here a term used is equipotential surface. So equipotential surface is a surface on which electric potential remains constant. No work is done in moving a charge along this equipotential surface. The system of charge is given as there are 2 points A and B, that is 6 centimeter apart, and on A there is a positive charge of 2 microcoulomb and on B there is a negative charge of 2 microcoulomb. We have to find out equipotential surface of this charge configuration. So let us proceed by general approach. Electric potential at any point P would be given by kqa by r1 plus kqb by r2. Now here qb is negative of q1, so we can write it as 2 into 10 to the power minus 6 by r1 minus 2 into 10 to the power minus 6 by r2 whole multiplied by k. Now for Vp to be constant, that is potential to be constant, r1 and r2 along the path should be constant. Now we know that the locus of a point equidistant from two fixed points is always a straight line representing perpendicular bisector of the segment joining the given point. That is, the locus of point that is equidistant from these 2 points should be this perpendicular bisector between these 2 points. Now the equipotential surface would be a plane located between the charges at a distance of 3 centimeter from each charge. The electric field at every point on the equipotential surface is directed perpendicular to the surface, pointing from positive charge of 2 microcoulomb to negative charge of minus 2 microcoulomb. Thank you.